Hi, I'm Janae Dixon. My co-author and advisor is Abdul Shakur Abuzned of the Department of Computer Science and Engineering at the University of Bridgeport in Bridgeport, Connecticut. I'll be presenting our paper on an NFC-based student attendance tracking and monitoring system using an IoT approach. Today I will be going over an introduction, the related work, key technologies, system architecture, including software and hardware, implementation results, future work, conclusion, and references. Introduction. Student attendance has a major impact on a student's likelihood of success in a course. When a student has more knowledge, everything that the teacher has prepared and equipped the student to fully understand the content that's provided in the course, then the student has a greater chance of succeeding in that course. Many professors understand this, and this is why many professors incorporate attendance as part of the overall grade. However, many do not actually have a reliable way of keeping track of which students are present at each lecture throughout the semester. Uh, Oftentimes, attendance is still tracked by hand by using a single sheet of paper that's passed around among students, and they write their name on it, and it's given back to the professor, and later he or she will go back and enter it into a system. However, this paper is easy to lose. If they're traveling from one place to another, it could be raining, it can get wet, and just like that, they don't have that on record, or it slips out their bag, or a lot of there are some other systems that people do try to implement, like taking a quiz as a form of a attendance. So they'll go back and they'll see who took the quiz and who didn't, and then use that as a form of attendance. However, it's not something that's very widely used today. There's some people who just opt to not do attendance at all because of the process that it takes to go through it. And since a lot of it today is basically just by hand, them going ahead and everyone writing down their name to track attendance and giving it back to the professor, and the professor has to go in and check who was here and who was there against a list on a database or on a website, and mark off who was here and who was not for every course that they have, and hope that this sheet is accurate and hope that nothing happens. It just can become very unreliable and time consuming and tedious. And also, students tend to write in their friend's name even when they're not there. So with today's technology achievements, an Internet of Things approach to student attendance and monitoring system would simplify and automate the process to make more professors want to track attendance, and allow a lot of professors who do track attendance to track it in a more reliable way. Um, so with many studies, there's already been many studies done using various methods of implementation. Our aim is to build upon the works that have been previously completed and present an attendance tracking monitoring system that can be easily adopted. The next 3 slides, I'll talk about some of the related work that we researched. It's just important to understand, it was important for us to understand what has already been done, what has worked, what may not has worked, will it work? So I'll just cover a few different works that we looked into, and for this sake, I'll refer to the references as by number, so reference 2, 3, 4. These references are the same as listed in the paper, and they're the same listed at the end of these slides. Um, so some IoT methods for developing an effective attendance and monitoring system we've seen include RFID technology using tags and mobile devices. There's biometric authentication, mobile or web-based user applications, and other communication technologies. Reference 2, developed and installed a system that uses terminals outside of the classrooms that have biometric authentication and near-field communication identification tags. So this author, this reference, they built these terminals that sit outside the classroom, and you have your fingerprint stored onto your student ID card. They're NFC cards, and these terminals scan your fingerprint, and they match. They use that fingerprint that they just recorded on the terminal and match your card. This is a very I think this approach is a very good approach. However, with large class sizes and unforeseen delays, this can really hold up lines and take away from class time outside. If one person is holding up the line, or there's an issue, maybe someone has a cut on their hand or something's going on, like, there's no real backup plan as far as what if the fingerprint doesn't work that day for some reason, or it just seems like this may cause some delays if there's any issues at all. Reference 3 and 4 propose solutions that use Android devices. They use Android applications. So reference 3, they propose a solution that uses NFC a student to identify a student, and also use a one-time password to authenticate. So upon the student enters the classroom, the professor has to have this NFC application open, and they tap their NFC ID on the phone. The reader reads it, and then it will text them an SMS where they have to confirm their identity. And with approach 4, it uses a mobile-based system that incorporates image capturing to authenticate the student, and uses a web application so they can view a concise report. Both of these may cause delays, especially the one where there's camera taking or picture taking. I mean, picture taking doesn't take too long, but I just feel like this method might not work very well with a lot of people coming in, and everyone needs to take a picture. And as far as the SMS, and both of these require having an Android device. All students have to make sure they have an Android device, and they bring it to class. And in our environment, some people have Android, some people don't. It's very here and there, but this system would have to be updated to these systems would have to be updated to reflect all major mobile devices, and it's just heavily Android based. And also all the professors would have to carry these Android devices as well. So along with the possible delays and the requirements of a working, especially the one-time password has to be working. It has to have a great connection. It does mention connecting to the school's Wi-Fi, but all that has to be in place for these both methods to work. So I'm not sure how well these methods would actually work in an environment, especially with larger class sizes. Reference 5, they designed a comprehensive system that includes RFID, student ID cards, and biometric authentication, as well as many different components and features. So each student must tap their ID card on the RFID reader and scan their fingerprint. The fingerprint is then sent to the server, where it checks for a match in the database. The attendance report can be viewed in both the web and mobile applications. So reference 2 and reference 5 have a lot of similarities, similar workflow with a few key differences. So in reference 2, the student's fingerprints are saved securely on an ID card and are matched at a terminal rather than sent over the server. Also, in reference to, the terminals are positioned outside of the classroom rather than inside, and only accessible for 5 minutes. So reference 5 decided to put a 5-minute limit on the terminal, and it's only accessible inside. and you scan your fingerprint and it'll send over the server and it'll match on the server. The reference 5, however, reference 5 also include a lot of interesting features. One of the features I really like and would definitely think is very good, would be very good to implement in this kind of system, is the use of hotspots. Which allows users to check where crowds are, how many people are on major locations on the campus, maybe at the dining hall, or maybe at an event that's going on, and also just the general number of students on campus. This would be very good, especially in a time like now when social distancing is very big. You don't want to be in a place where there's just a bunch of people around, or you would rather want to know what your wait time is before going there. This is something that would be very interesting to include. However, it's just an added bonus. So while features like that are a great bonus, I feel like reference 2 presents a really good system that's a lot more practical, since there's no time constraint, and fingerprint templates are not stored on the database. So the time constraint of 5 minutes, that's very short, because a lot professors are late, students are late sometimes. Does that mean you shouldn't track their attendance after 5 minutes? I mean, that's up to the professor, but that's a very short constraint. And also the fingerprint being stored on the database, that might lead to some cybersecurity problems. Having a bunch of students' fingerprints stored in a database where they have to use that to match for attendance, that might be not the best idea to do because of security reasons. So I like both these approaches, but I think that the way that reference 2 is going is a little better. However, with all the works that I've discussed and I've researched, I realized that there is one aspect they all have in common. There's a single point failure. Each system in all these different tracking and attendance systems, they all rely on one near field communication reader. Having a single reader can be disruptive and take away time from a lecture if students and professors are late or a line begins to form. So if professors are late all the time, I mean, I've seen it. Students are late. If there's lines, um, if students are late and professors are late, and there's one place to track attendance, and all the students are there, then all students have to get up and one by one go to this reader and start taking attendance. And if a professor's late, likely he wants to just jump into the lecture and just get going. But if they're late and everyone has to start recording attendance, that might take time. And also, if a student is late and the recording system is right in the front of class, it's going to, one, draw all the attention away from the lecture to the student, and it's going to just continually interrupt if there's more and more people late and they still allow attendance. And say there's multiple people late and a line starts to form. So it just seems like having one single point where the NFC reader is the end all be all, and that has to work for the system to work. Doesn't sound like the best way to go in a university environment, because there's a lot of movement, there's a lot of coming in, coming out. So uh, I uh, so I think it's best that we alleviate the single point failure issue. So because of the disruptiveness of students and being late and it interrupting time, possible lecture time, I can see why many professors still favor passing around a paper of an attendance sheet because it can be done quietly with little distraction. Someone who is late can just the paper can be passed down the to the desk to them, and it's very little distraction. So the ideal attendance tracking system and monitoring system would be able to achieve the same goal as the paper did with the same amount, the same of quietness, the same um, amount of limited distraction, with the added bonus of the reliability, the simplicity, and automation. So we're proposing a system that incorporates aspects from the related work that we've researched and developed a fully automatic attendance tracking and monitoring system using IoT to create a one-to-one solution between the students and the NFC readers. Some key technologies that we use in our model are message queuing telemetry transport protocol, MQTT. This protocol allows for bi-directional communication and will enable devices to be controlled remotely. There are two types of network entities, a message broker and its clients. The message broker is responsible for receiving all messages, filtering them, and sending them to the appropriate clients. The clients are the devices that can connect to the broker and send and receive messages. In our model, the IoT hub acts as the message broker, and the clients are the NFC reader devices. Also, we use near-field communication. Near-field communication is short-range wireless technology that allows communication between devices when they are touched together or brought within a few centimeters of one another. This is a specialized subset of RFID technology. In our proposed system, NFC is used in the student ID card and the reader devices that we want to locate at each desk. The NFC tag in the ID will hold student ID number. And these are just the different modes of NFC. There are 3 modes: reader-writer mode, peer-to-peer mode, card emulation mode. So in reader-writer mode, there's a passive tag and there's an active device, and the active device writes and reads from the passive tag. The peer-to-peer mode can send data between 2 active devices. And card emulator, one is a passive device, the other is an active device. The passive device acts as a card. So, and it emulates having a real card. So in our model, we use NFC and peer-to-peer mode to simulate. However, in an actual implementation, card emulation mode would be used. Card emulation mode is much more secure. It requires the use of a tamper-resistant secure element. It also implements cryptography using keys to encrypt and decrypt. It's used today in many of the bank cards and apps with authentication cards. Here is a workflow of the simulation that we used. So we have an NFC target tag. The target tag stores the student ID that is connected to an Arduino Mega. So the user will take the target and tap it onto the NFC reader device. The reader device is connected to a separate Arduino Mega that will collect the data from the tag, and then it'll process it. It'll create an MQTT message containing the ID, time, seat number, any information that we decide to include, and then it'll process it over the Mega, and it'll send it to the Node MCU Wi-Fi module, which will send to the Azure IoT hub through the MQTT protocol. The Azure hub will receive the message, it will filter it out, and it will place it into the correct table into an SQL database. And from there, the web application can pull the necessary data to check attendance and display it to the users, most likely the professors. Here's just some images of the hardware that we use to simulate. So at the top left, we have an NFC module. On the top right, there's a NFC, there's a Node MCU Wi-Fi module. This is how we sent the MQQT message over the internet to the IoT hub. At the bottom left, we have the two pieces together that will simulate the student ID. So we have the target, the NFC tag, and then on the bottom right, it will simulate the NFC reader with the reader and the Node NMCU Wi-Fi module connected to the Arduino Mega, as shown in the previous slide. So that's what these look like. Okay, system architecture hardware. So we have the student ID card. In our system, we propose the use of a secure NFC cards that utilize data encryption similar to the MyFair DeskFire to protect the student's information. DeskFire uses 3DS or AES hardware cryptography engine for inside-preferring transmission data. To simulate the NFC card, we use an Arduino Mega with a PN532 NFC module. The NFC module holds only a student ID number. Also, the desk with the NFC reader, processing unit, and Wi-Fi. In our model, we're proposing a wireless device with NFC reading capabilities to be built into desks as part of a smart desk. Smart objects are on the rise. Several works have proposed smart desks and tables. We see that this can be something that can be implemented within these tables as part of those architectures. It's if they can be created into small devices that can be used to send data. All you need is the modules to send data to the certain IoT hubs or processing hubs that can handle that. In our model, we use the Arduino Mega for processing, the PN532 NFC module to read the student ID card, and an NFC and a Node MCU to send the IoT messages over Wi-Fi. Messages are sent from the Arduino to the IoT hub using the MQQT protocol. The message contains various information to identify the student, course, and sign-in time. The system architecture software. So we have an Azure SQL database. That database is a cloud-based SQL database. It simply stores each data's attendance record and any information we need for the web application. It acts as a backend for the web application. Also, we use the Azure IoT Hub. These are Microsoft applications. Azure IoT Hub is a cloud service that acts as a middleman between an IoT application and the device it controls. Can control these devices from anywhere in the world. It allows for two-way communication between the cloud and the device. In our model, using Arduino with the Wi-Fi module, we send messages to the IoT hub over the MQQT protocol to then be stored in the database. We also have a web application where we can easily view the attendance. So implementation results. On the left is an example of the web page. On the web page, we have name, ID, seat number, status, sign-in time, just overall percentages. This would be the screen that's presented to each professor after they chose the lecture, the date of the lecture, so they can go back and review. In this example, I have all the sign-in times are the same because it was done with some of them were done with the simulation. However, example student ID 4 was captured with the actual Arduino device, and so but everything else is mixed in with it because I needed to simulate a specific class size so I can test out the web page and so we can test out the web page and everything. But this is just an example of what the web page would look like. And on the right, we have the screen capture from the IoT hub. So if we look at the blue line is the input received from the Arduino, from the reader. So this is the input we're receiving from the reader. It's sent from the reader to the Arduino, and the Arduino has to filter it. Blue line is input and orange is output. This one's kind of reddish because there's some overlap between the blue and the orange. But if you see that the number of outputs is less than the number of inputs, that's because some of those messages didn't correspond to what the requirements were for it to save within the database. So this is the input and message traffic around the same time as this. I tried to zoom in here, but this says 9:45, so there was some output around 9:42 here, if you look at the orange line, but there was several inputs around this time for the coming in at the blue line. But the data successfully saved into the database, and I was able to look at pull the data from various classes. I had various simulation situations. The data sends to the IoT hub, and then it stores into the SQL database, and from there I can pull the data onto the website and view it. Future work, there's biometric authentication. Many of the works that I discussed earlier include biometric authentication. I agree with this system. I agree with incorporating it. I think that it's a good way to go to fight cybersecurity risks that would likely arise with developing these systems. Also, protect against students writing down their friend's name or their peer's name. And then if the system becomes very reliable and very secure and very good at individual authentication, then it can be used on a wider scale for tests, for tracking, for individual authentication for many situations on the campus. It'll just provide a greater level of security against unauthorized users. I think incorporating fingerprint scanners are the best way to go. Fingerprints are very, very accurate, more accurate with the more fingerprints. So I'd say maybe 2 fingerprints, just to be sure. And also say you get a cut on one finger that day, you don't want that to be the end all be all. So I would really like to incorporate biometric authentication. Also, to continue to further develop the website, there's a few things I would like to add to it, and just to continue to work out everything to make sure everything runs smoothly. And in conclusion, we propose an attendance tracking monitor system that utilizes RFID and other IoT technologies. Our implementation was successful in recording student attendance using our models. The NFC reader extracted the student ID from the NFC tag and sent it to the database over Wi-Fi. We were then able to view the record in a web application. In similar studies, they present reasonable ideas in their work. However, many provide no solution to the possibility of a bottleneck. Our proposed system removes the prospect of this occurring and creates an environment where attendance tracking is simple, quick, convenient, and distractionless. And here are my references. This is the same references as listed in the paper. Thank you.